All right, if I give you the function negative x squared plus 2x plus 3, okay, and I want you to graph it, and I give you some x values, what are you going to do with those x values? Plug them in, okay? We're only going to plug them in where I see an x, so that negative is still there. The squared is still there. Plus 2, and then plus 3, okay? Those pieces will never change. What's changing is what I plug into the parentheses each time. Right? So the first one, my x value is what? Negative 2? So we're going to plug in negative 2. PEMDAS tells me to do exponents first. So what is negative 2 squared? 4. That negative is still out the front. Then over here, what is 2 times negative 2? Negative 4, and then plus 3. So what is negative 4 minus 4 plus 3? Let's see, that's negative 8 plus 3, which gives me negative 5. Okay? Well, that's all we're doing today, for the most part. We're just going to apply it to real-world stuff. So how would I figure out negative 1? I would plug in negative 1 to each spot. So now, what is negative 1 squared? Positive 1. That negative is still out the side. 2 times negative 1? Negative 2, and then plus 3. Which gives us 0. All right, how about you plug in 0? You do it. So now it's going to be negative 0 squared plus 2 times 0 plus 3. Jaguar thinks it's 3. What do y'all think? Jenny, what do you think? You don't know because we're not trying? What is 0 squared? 0. Negative 0 is just 0, right? What's 2 times 0? 0 again. And then plus 3. So what do we get? 3. Let's try today. We're here. I'm still a teacher. You're still a student. We're still trying. All right? I would like you to please plug in the rest. Let's see if we can find the rest of my table. All right, what'd you get when you plugged in 1? We got a 3. We got a 1. Let's see here. 1 squared is 1. There's still a negative out front. Plus 2 times 1, which is 2. And then plus 3. That gives me positive 1 plus 3, which is 4. When we plug in the value of 2, we're going to get out a 3. Plug in 4, we get out a negative 5. Tell me some things you notice in the table. There's 2 negative 5s. And there's 2 3s. Okay? So my y's are repeating, which is okay. So what kind of graph do you think we're about to see? Plot them. Plot the points. So we have negative 2, negative 5 down here, right? Negative 1, 0. 0 up to 3. 1 up to 4. 2 goes back down to 3, and then 4 goes down to negative 5. Something like that. What kind of shape did we just get? Oh, a parabola. What part of my function could have told me that's what I was going to get? What part of this could tell you that I was going to get the shape of a U? What part of the function tells you you're going to get a U-shaped graph? What makes it a parabola? What makes it a quadratic function? The x squared. An exponent of 2 makes it a quadratic equation. So that told me I was going to have a parabola. The negative told me it was going to be an upside down parabola. Okay, so that piece gives me an indication it's going to look something like this. We just found exactly where it was going to go. All right, let's start applying this to real world things in your books, page 153. All right. So now we have someone jumping into a deep pool of water from a diving board that's 25 feet above the ground. Your height with respect to time can be modeled by the function they gave me, 25 minus 16t squared. I see a t squared, I should expect some kind of curve, right? This is going to be a quadratic. T is time in seconds. So I want this to complete the table below. So when I'm plugging in values, what letter am I going to replace? I'm going to replace the t. Okay? So 25 will always be there. Minus 16 is always there. I'm replacing the t each time, but the squared is also still always going to be there. Okay? So the first time we're going to plug in right here, we're going to do a t equals 0 first. So we're going to put a 0 right there. Correct. Right. We could not get negatives out of it. All right, PEMDAS again tells me parentheses and then exponents. So I need to do 0 squared first, which gives me 0. Now I get to multiply or divide. So what's 16 times 0? And what's 25 minus 0? 25. Doesn't that make sense? Think about it. Where did the divers start? Where did they start? On a diving board. And where's the diving board? It's 25 feet, right, off the ground. So it makes sense that our first value is 25, okay? Please don't write just the number 25. Please show where you got it from, okay? Right next, there's a whole blank space next to you if you need to use it, okay? We'll wait for the graph. So it makes sense that we start at 25 because the diving board where he jumps off of is 25 feet off the ground. All right, what value are we going to plug in next? 0.25 is going to get plugged in next. All right, what is 0.25 squared? Please don't guess. I want you to actually please type it in. 0.25 squared. 25. Please do not guess. Please type it in. 0.0625. Do not guess. Type it in. What is 0.0625 times 16? Yeah, it's 1. And what is 25 minus 1? 24. So at 0.25 seconds off of the diving board, he is now down to 24 feet. So he's traveled 1 foot. Makes sense, right? That's pretty quick. He's barely off the board, so he should barely be down. All right, what are we going to plug in for the next one? Just 0.5. Good. Let me get rid of these pieces. Boop, boop. All right. Plugging in 0.5 this time. What is 0.5 squared? Point what? 0.25? Is that what you got? Yes? So we have 0.25. What is 0.25 times 16? 4? Jenny, you got 4? Yeah. And what is 25 minus 4? Woohoo! Beautiful. Let's do 0.75. All right, 0.75 now. So what part are we going to do first? Yeah, we're going to square it. So what is 0.75 squared? Okay, someone else do it. So what you got also? What? 0.5 5, 6, 2, 5. Okay, what is that times 16? 9. And what's 25 minus 9? We're not square rooting, we're squaring. You push the square button. The one that has a square on it. All right, how about you finish this table? Plug in 1, and then also plug in 1.25. Again, if all you have on your paper right now is 25, 24, 21, and 16, you're doing yourself a disservice. You need to know where these are coming from. Okay? You have to be able to create these numbers, not just copy them off a TV screen. All right, so we're plugging in 1 now. What was 1 squared? What is 16 times 1? And what is 25 minus 16? So your next spot should be 9. All right, the final blank, we plugged in 1.25. What is 1.25 squared? 1.5625. All right, times 16. What is 25 minus 25? 0. Good. Good. All right, now we're going to graph it. So the table will still be there. This table's at the top.
How do you know which one is X and which one's Y? And how do you know what to go by?
Okay, so X is what you're plugging in.
Yeah.
So we're plugging in time. So we're going to have time be my X-axis. And my height's going to be the Y-axis. And I'm going to give you how to mark your axes. So go ahead, have your time at the bottom. Go 0.25, 0.5, 0.75. Let's just put it right here. Deal? Don't touch it. Let's have our height and feet on this side. Let's go by 3s. All right, so you are labeling your graph right now.
I'm not even going to try.
All right, so we start off with an X of 0, a Y of 25. Then at 0.25, we're up here at 0.24. And then it goes on. So notice as we are moving across the graph, we are decreasing. Does that make sense? What was this showing? What was this showing?
It was showing.
What's the situation?
The elevation was going down.
No. The situation of the problem was someone diving into a pool.
Oh yeah.
Does that make sense with what you see?
Yes.
Does this look like somebody is diving off of a diving board into a pool of water? Yes, it makes sense. Okay? It makes sense. Now,
Drawing on point.
how come I'm not showing the other half of my graph where he's falling over there in the water?
That's not water, that's straight concrete.
You can't dive into concrete.
It's not about concrete. What is it? Okay? And we can't go in negative time, can we?
You're right.
We cannot go negative time. So this does not exist in real life. Okay? And there's probably a ladder right here that our swimmer climbed up and then jumped off of. Right? Yes, sir. What? Sure. All right? So that is why. So this makes sense. Make sure your graphs make sense. Okay? Like on your projects. Make sure your stories make sense with what your graph is doing. All right, we got about 15 minutes.
I drew your picture.
Okay, hey, thank you.
Yeah, you should be an artist.
Yes.
Math teacher.
Okay. I am going to skip this problem because I like the other one better. We can come back to it if I have time. Boop, boop, boop. Okay, I'm going to do this one and then we'll come back to it, okay? So, we have a business owner and sales. So we're on the next page that there's a table already given to you, and the graph is on page 155. So flip over. Okay? A table's already been made. They have the months January through December, and it has sales in thousands of dollars. Okay? Yes, sales will be my Y, and months will be my X. So I want you to go ahead and mark those. All right, so your X-axis is your months. Your sales on the side is going to go, I went from 0, every other thing I did, 20, or you can mark each one 10, however you want to do it. It is your graph, you do you. Okay. How I pick these numbers, well, obviously the months are given to us, right? I have no choice there. If I look at my Y's, I see that the lowest Y is 5. I see my highest Y is, what, 71? Yeah. So I know my Y's have to at least get up to 71. Okay, so I have to be able to show all those pieces on there. All right, once you label these, go ahead and graph these points also. This is going to model business sales. We don't know what business. It's going to model something, though. All right, so our graph looks a little bit like this, okay? So this is modeling business sales. So there's not a dot at 0, 0 because that's not part of my data. My data starts at January, so my first dot is January and then the $22,000 in sales, okay? I'm not doing arrows because we're only going January to December and we're stopping. Okay, what kind of graph did we just get? We got a parabola, good. Okay, next question. What kind of business do you think this might be? What do you think? Some kind of summer thing? Why does he say that? Why does he say? Where does it peak sales at, though?
During the
Its highest sales, yeah, look right here. It's definitely the summer months. So what kind of businesses are in the summer? Let's get more specific. Summer camp. What'd you say? Water guns. What else?
bunch of balloons. The balloons that you put in the
Water balloons?
water balloon thing.
All right. How about, I mean, we're making $70,000 in a month. Maybe they're installing pools.
Getting 4-wheelers.
Right? That's not a summer thing. Dang. Summer thing. Okay? So we can pick the one you like best. I have smoothies, ice cream pools up there. Okay? It's some kind of a summer business. So for your part B, pick a summer business. A water park. A summer camp. Okay? We recognize this because it peaked in the summer months. So we are making the conclusion this is a summer-driven business. Now, what kind of model should they use? Should they use a quadratic model, like equation, or should they use the equation of a line? Which one? Like if they were creating something, should they put it in this format? That's the quadratic. Or should they put it in this format? What represents the equation that we see? Yeah, because it became a parabola, we should use the quadratic model. Okay? So it says, would the quadratic model be best? Yes, it would. Because our pattern follows a parabola pattern. Put that where you can see it. Your project. Okay? So this is a line, which we don't want. This showed a quadratic, which is what's forming over here. So this is the one that we like for this model. Okay. All right, so now let's go back to the other one. The one with the CEO construction business.
Hold on.
Okay. You don't have to flip pages. Just look on page 154. Questions on this one? Okay. Let's go back. Boop, boop, boop. To this guy. Okay. A construction company builds houses on square-shaped lots of various sizes. The CEO of the company decided to diversify her lots and now has houses built on rectangular shaped lots that are 6 feet longer and 4 feet narrower than her square shaped lots. So it wants us to create a function that models the size of the new rectangle lots versus the square lots. Okay, so a square lot looks like a square, right? I would draw that in part A. Okay, that's what the square lot looked like. Each side was X feet long. We don't know how many feet. Okay, she changed them to rectangles. So how much longer is the rectangle going to be? What does it say?
4 feet.
How much longer is it?
6.
It is 6 feet longer. So how would I add 6 to my side of X? I would make it X plus 6, right? Right? And if we're narrow, that means I'm losing feet. So the other side is going to be what? X minus 4. Yeah. So draw your new rectangle. That's the new lots.
Is this in the book?
Okay? It is in the book. It's right here.
Oh.
So yeah, you're drawing the square and rectangle. And then we're going to find the area of the rectangle is what we're going to do. Okay? It wants us to find a function to represent the area of the lot. Okay? So was it smart for the CEO to change the size of her lot? That's pretty much what we're trying to figure out. Okay? To change the shape, is there more land for her to create a house? This is what we're trying to figure out. Okay? So, how do we find area?
Number times the number times the number.
It is length times width. Okay? So, for my rectangle, what's my length?
6.
X plus 6, and my width is going to be X minus 4. Okay? So to find the area, we're going to multiply them together. So we're going to do X plus 6 times X minus 4. How do we multiply binomials together? Starts with an F, ends in oil. Foil. Okay? So that means we're going to take X, multiply it to X and negative 4. So that gives me what? X squared and negative 4X. Then we're going to do the same thing with 6. 6 times X and 6 times negative 4. That'll give me a positive 6X and then a minus 24. Yeah, combine like terms. This gives me X squared. What is that? Plus 2X. And then minus 24. So that is the area of our rectangles. What's the area of our squares? I know it doesn't ask you this, but this is the area of the rectangle. What's the area of the square one over here?
1?
Almost. Nope. What's length times width, guys? What is X times X? X squared.
Oh.
Yes. Okay. So the area of the square is X squared. The area of the rectangle is X squared plus 2X minus 24. So we're trying to see, did she create more land to make houses on? Okay. The more the better, because she can make more money, right, if there's more land. So from here, we're going to start plugging things in. We're going to compare the area of the square to the area of the new lot. Okay. We're going to use that by using this new function. Okay. So that's going to represent our rectangle. And then this over here is our square. Okay, I'm going to tell you what values to plug in because they are houses. We're going to use, excuse me. There we go, 50, 55, 60, 65, 70. Okay, that is the area of the square lots. Or that's the side of a square, right? If we plug that in, we can find the area of the rectangle. So, I'm only replacing where I see an X. So, something squared plus 2 times something minus 24. All right. We're going to plug in 50 first. What is 50 squared? Okay. 2 times 50 is 100. So I need to know 2,500 plus 100 minus 24. What does that give me? That should give me 2,576. All right, we're going to repeat this process over and over again because now we're going to do it again, but we're going to plug in 55. So what is 55 squared?
3,025.
3,025.
Okay, plus 2 times 55 is 110. So what is 3,025 plus 110 and then minus 24?
2,999.
That's 3111.
3111. All right, for time's sake, I'm going to help you out with the rest of our values. Okay, so if we look at the square lot size versus our rectangle lot size, and we plot these points, was it a smart idea to change those squares to rectangles? Is there more area? Oh, yeah. There's a bunch more area. Okay, so I would just do a sketch there for you. All right, so it's definitely giving us more area to build the houses. So the CEO made a smart choice. Okay, your project 3 is your homework. I'm not going to stamp it until Monday because you do have a quiz tomorrow, so I want you to focus on doing that also. But you're making a T-table for your function. When you finish your quiz tomorrow, you can do that in class tomorrow too. So make sure you have your project sheet with you.